Hi everyone. Today we are discussing about the subject low power VLSI design. So basically this is the one of the important subject related to the electronic student, and the prerequisite subjects required for this subject are VLSI design and digital electronics. So in previous semesters already we studied about these two subjects. So low power VLSI design. So the name itself indicating while designing the circuits, the designer should more concentrate on the power. Means designer should design the architecture or circuit to reducing the power consumption in integrated circuits without compromising its performance. So mainly it is focusing on the reducing the power consumption in integrated circuit. So coming to this introduction, in olden days, in VLSI design, millions of transistors can be fabricated in single chip. But in olden days, in VLSI design, it focuses on only two parameters. Those are area and speed. But coming to this, but low power VLSI, whenever the technology is, whenever the technology is coming to this, here technology, submicron technology, technology is shrinking from 1 nanometer to another nanometer. Means suppose here 130 nanometer to 90 nanometer, 90 nanometer to 65 nanometer, 65 nanometer to 22 nanometer. Whenever the technology is shrinking, uh, the power related, power consumption related problems are occurring in the chip. So majorly, the power consumption is more on increasing the number of transistors in an integrated circuits. So to get the high speed, definitely the number of transistors are more, and those are consuming the more power. So we need to designing a circuit to consuming the less power without compromising its performance. So whenever the power density is more, maybe it leads to the failure in the chip because of high temperature. So mostly nowadays every electronic gadget is battery operated devices. So majorly we are focusing on reducing the power dissipation in batteries. If you suppose if you are not reducing the power consumption of the battery lifetime will be very less. So by using different techniques, possible different techniques, that may be either power gating or clock gating or different ways reduce the supply voltage and different voltage scaling techniques. So by using different techniques, we can reducing the power dissipation of a circuit. So if you observe, basically the performance of a processor is indicating in millions of transistors per second, means speed. So the power consumption was the secondary concern while designing the ICs. But coming to the, however, we are moving to the nanometer technology, submicron technology. Power has become most important issue because um, whenever the technology is shrinking, definitely the transistor count is increases continuously according to the Moore's law. And high speed of operation. Definitely, we are increasing this transistors count to get the high speed only. So, whenever the system is having high speed, it obviously requires more power. So, these two are direct proportional relation. If those are having high speed, definitely those requires the more power and greater leakage currents. So, whenever uh, the technology is shrinking down, the leakage currents is also more. That's why the power consumption is considered one of the most important parameters, one of the most important design parameters. So generally, to removing the heat generated by the device, it is necessary to provide some suitable packing and cooling mechanisms. But whenever we are using these cooling and packing mechanisms, those are increasing the cost of that IC. So it is necessary to make a chip commercially viable to reduce the cost of packing and cooling, which demands to the low power consumption. And we know it has been found for every 10 degrees rise in temperature, roughly doubles the failure rate. That's why low power dissipation of a device is essential for reliable operation. And the power is dissipated mostly in the form of heat only. So, and the cooling techniques required to uh, compensate that one is air conditioner or transfer the heat to the environment. Also, transfer the heat in environment we can observe in the industries. And generally, to cool the device, we are using the air conditioners. So, coming to this, first of all, to reducing the power dissipation in a circuit, we should know what are the different sources of power dissipations. So, this is coming to this. This is the diagram to indicating the sources of power dissipation. So, power dissipation means the power dissipation is generally indicated in the form of heat. So, that is divided into two types: dynamic power and static power. Dynamic power is nothing but the power consumed by the device whenever the device is active. That is when the signals of the device are changing the values. Means dynamic power is the power consumed when the device is in active, and as well as in the situations the signals of the design are changing its values. And this is categorized into three types. Those are switching power, short circuit power, and glitching power. So if you observe in this diagram also, the power dissipation majorly divided into two parts: dynamic power and static power. So dynamic power means here the device is in active, and in that also the signals are changing its values, means that is the device is in the operation state. So the dynamic power is categorized into three types. Those are switching power dissipation, short circuit power dissipation, and glitching power dissipation. And coming to the static power, the static power means here the device is in active, but that is not doing any work. Means the signal values are not changing. That is in the ideal state only. Majorly, the static power is nothing but leakage power only. So that is categorized into sub-threshold leakage, gate leakage, junction leakage. So majorly, the static power is nothing but leakage power only. The device is in active state, but it is not doing any work. Means the device is only on state. That is not doing any function. So maximum all these are leakage currents only. Different types of leakage currents at occurring at different stages of IC. So subthreshold leakage, gate leakage, junction leakage. And again the subthreshold leakage is categorized into different types: drain induced barrier lowering, body effect, narrow width effect, channel length modulation, temperature effect, gate induced leakage, channel punch through effect. And gate leakage is gate oxide tunneling, hot carrier injection. Junction leakage is reverse bias junction carrier and band to band tunneling current. So these are the different types of static power dissipations. So dynamic power means the device is in the active and the signals are also changing its operation, means that is in the operation stage only. So dynamic power is also called as active power. Static power, the device is on only, but the signals are not changing its values. So static power, another name is leakage power. Mainly it is focusing on leakage power only. If you reducing the leakage power, mostly probably you can reducing the power dissipation of the circuit. Why? Because the total power dissipation is equal to the addition of dynamic power plus static power. And this is the uh, important diagram, and this will indicating the sources of power dissipation. How what are the different ways the power is dissipated? Yes, the dynamic power is divided into three major types: switching power dissipation, short circuit power dissipation, and glitching power dissipation. Okay, this is the diagram related to the sources of power dissipation. Next dynamic power dissipation we'll discuss in the next class. Thank you.